Here's the first set of review problems for you to practice. So as I show you each one, pause the video, look back in your notes, give the problems a try, and then resume playing to check your work. So in question 1, I'm giving you f of x is equal to x plus 2 over x. I want you to find the inverse of f of x. Go ahead and pause the video to give this a try. All right, if you need more time, pause the video again. First thing we want to do is just replace f of x with y, so we'll start with y is equal to x plus 2 over x, and this is where we switch x and y, so x will equal y plus 2 over y. Now we have a couple of y's here, so my next step is to multiply both sides by y and then get all the y terms to one side. So I'm going to get xy is equal to y plus 2. I'll move this y over by subtracting. And to go from seeing two y terms down to 1, we're going to factor out a y, and we'll have x minus 1 left. It's equal to 2. Then we'll just divide both sides by x minus 1, so y is going to equal 2 over x minus 1. And that's our inverse, therefore we're going to write it this way. The inverse of f of x is equal to 2 over x minus 1. Now as you're just practicing these, you can always check. If you go to Desmos and you graph f of x and then you graph the inverse, and then also graph the line y equals x, and both of these graphs should reflect over that line y equals x. So this problem was from section 6.1. This is also from section 6.1. We're going to let f of x equal the square root of 3x minus 2. We want to find the derivative of the inverse of f at 1 using the theorem. And then we're going to check by finding the inverse first and then finding the derivative. So pause the video again, look this up in your notes, see how you do. All right, so the formula from the theorem, what we're looking at here, is that the derivative of the inverse of f of x is going to equal 1 over f prime of the inverse of f of x. So in this case, if we substituted in a 1, this becomes 1 over f prime of the inverse of f of 1. So this is what we want to calculate first off to the side. So we're going to say the inverse of f of 1 is going to equal u. Therefore, if I substituted u into our function, I'm going to get 1. So then what I do is I set the square root of 3 times u, though, minus 2 is going to equal 1. And then I solve for u. So I'm going to square both sides. So we'll get 3u minus 2. 1 squared is just 1. Solve for u here. So 3u is going to equal 3. And then u is going to equal 1. So going back up here, that's going to equal 1. So now this becomes 1 over f prime of 1. Well, now I have to find the derivative of f of x. So if f of x is equal to the square root of 3x minus 2, f prime of x is going to equal, remember we could write this as the quantity to the 1/2 power. Use the chain rule, so we're going to have 1/2 times 3x minus 2 to the negative 1/2, then times the derivative of the inside stuff, so 3. So then this becomes, to rewrite this, I'm going to have 3 in my numerator over 2, then this part here becomes 3x minus 2 to the positive 1/2, or the square root of 3x minus 2. And then I'm going to evaluate this at x equals 1. So I get 3 over 2 times the square root. 3 times 1 is 3, so 3 minus 2, that'll just give me 1. So then this will just equal 3/2. So now I get 1 over 3/2, which is just the reciprocal. So this gives me 2/3. So remember, we can always check this. So if I ask for you to use a theorem, I want you to do the method I just showed. Here's the way to check. Again, first, let's let y equal the square root of 3x minus 2. We're going to find the inverse first. So I'm going to switch x and y, and then solve for y. So I'm going to square both sides. So x squared is going to equal 3y minus 2. Add 2. Divide by 3. So y is going to equal x squared plus 2 over 3. So my inverse function So now when I go to find the derivative of this, again, I could rewrite this as 1/3 x squared plus 2/3. And then the derivative of this just becomes 2/3 x. And then when x is 1, I get 2/3 times 1, which is also 2/3. All right, some problems from 6.2 are going to come a little bit later. So this one is from 6.3. F of x is equal to the natural log of this quantity. I want you to find the derivative. So a hint here, use the properties of logarithms to rewrite this expression, but go ahead and pause the video and try this on your own. All right, so again, before we start to take the derivative, let's expand this now. So I know I have a fraction here, so I want to expand this first by subtracting. So we'll take the natural log of 5x squared minus the natural log of this quantity to the 6th. And I'm multiplying here, so I could expand this first part by adding. So we'll say the natural log of 5 times the natural log of x squared. And then over here, and again, if you're comfortable enough with these properties, you can skip some steps. So what I could do with the last one is just bring that 6 down in front. And we could have also done that, and we're going to go back and do that. That should have been a plus sign right here. So we have the natural log of 5 plus 2 times the natural log of x minus 6 times the natural log of 4x minus 2. And now we'll take the derivative. So the natural log of 5 is just a constant. So the derivative of a constant is 0. Next, I'm going to get 2 times the derivative of the natural log of x. So that becomes 2 times 1 over x. And then over here, this becomes minus 6 times 1 over 4x minus 2. That's the derivative here. But then times the derivative of the inside stuff, so then that just becomes a 4. And then we'll clean this up. We'll have 2 over x minus 24 over 4x minus 2. And then we could simplify that last fraction. So we get 2 over x. Divide everything up here by 2. So we get 12 over 2x minus 1. All right, this is also from section 6.3. Again, pause the video to try this on your own. Okay, so let's see what you were coming up with. First, we want to use the inverse of e to some power, and that's going to be to take the natural log of both sides. So what's going to happen here, we could use the property of logarithms first, that we're going to say 5x minus 1 comes down times the natural log of e equals the natural log of 4. Natural log of e is really 1, so then that just goes away. So that's why we could just skip to this step and say natural log of e to some power is just that power. And then solve for x. We're just going to leave this in exact form. So we'll say 5x is going to equal natural log of 4 plus 1. And then we divide that whole thing by 5. Okay, so this is a combination of section 6.2 and 6.4. So go ahead and give these a try. And I'm actually going to go ahead and add one more here. All right, so there's another one. All right, pause the video if you still need more time. Let's go ahead and take a look at these answers. All right, so A and B are both looking at derivatives of powers of E. So for A, our derivative is going to be e to that power times the derivative of that power. So we could think of 1 over x as x to the negative first. So then this becomes times, we'll have negative 1 times x to the negative second. And you could leave it like that, or you could say e to the 1 over x times negative 1 over x squared. And you could leave it just like that. For b, g prime of x, same process. We'll have e to the x squared plus 2x. Then we just take times the derivative of that exponent, which just becomes 2x plus 2. Now for c, we practiced this before. The natural log, the derivative of this. So this becomes 1 over sine x times the derivative of sine x, which is cosine x. And you could leave it just like that. Right now for D, we have to go to the derivative rule for log base A. So this is going to become 1 over whatever u of x is, so this 4x squared minus x, times the natural log of A, so then times the natural log of 5, then times the derivative of the inside stuff, so then this becomes 8x minus 1. All right, so number 6, use logarithmic differentiation to find our derivative if f of x is equal to tangent x to the 1 over x. Okay, so pause the video if you need more time. If not, I'm going to go ahead and start this. So what I first want to do is just rewrite this as y is equal to tangent x to the 1 over x. So what we want to do next is take the natural log of each side because I want to get this exponent to come down. Not yet. Natural log first. So now that exponent can come down. And now I can use the product rule over here. So when I start to take the derivative of the natural log of y, that becomes 1 over y, implicit differentiation here, so then times y prime. And then I have my u, which is 1 over x, times v prime, so this becomes 1 over tangent x, then times the derivative of tangent x, which is secant square x. So there's my uv prime, plus vu prime, so v is the natural log of tangent x. And here's that 1 over x again, or x to the negative first, so then this becomes negative 1 over x squared. So now what I want to do is get y prime by itself. So I'm going to clean up this right side here. So I'm still just going to leave it as 1 over y times y prime. Here I could just write it as x times secant square x over tangent x. No need to do anything else with it. And then we'll say minus natural log of tangent x over x squared. Now I want to multiply both sides by y. So y prime is going to equal y times this quantity. And then I just replace y because I want everything in terms of x. So we just go back up to the beginning, and y is equal to tangent x to the 1 over x. So I just replace that. And there we go. All right, and the last example, bringing in some integrals. So go ahead and try these on your own. So to give you a hint here, you do want to use u substitution, unless you think you can come up with it without using it. Once you use it enough, you might be able to kind of picture the parts, the pieces in your head All right, if you need more time, pause the video again, but let's go ahead and try this. So for the first integral, I'm going to go ahead and let u equal the natural log of x. Now to go through this process a little quicker, there's a couple ways we could look at this. I always show du over dx, but we know we're going to end up multiplying both sides by it, so then this becomes 1 over x dx. Now, if I were to rewrite this, I could rewrite this as 1 over x times the natural log of x times dx. Well, right here, du is equal to 1 over x dx. So now I can just go ahead and substitute this in. I know the natural log of x is u, and then what's in blue here is just the du. If not, you could still show the steps where things cancel. So I could still show that dx is going to equal x times du, and then I could still write this out as 1 over x times now u. Dx is x du, and then this is where the x's cross out. So there's both ways that you could do this. So now this becomes the integral of u du, and I simply take the antiderivative here. This is really u to the first, so it becomes u squared over 2 plus c, and then bringing back what u is, it's the natural log of x, this whole thing squared, over 2, or 1/2 times it, plus c. All right, for b, I'm going to go ahead and let u equal 1 plus e to the x. That way du is going to equal e to the x dx. So here we are again. There's e to the x dx, so that's just du. So now this can become the integral. This whole thing right here, 1 plus e to the x is u, so the square root of u is u to the 1/2. And again, e to the x dx is du. And then taking the antiderivative here, I'm going to add 1 onto 1/2, so it's going to give me 3/2 over 3/2 plus c. So dividing by 3/2 is the same thing as multiplying by the reciprocal, u to the 3/2 plus c, and bring back what u is equal to, so we get 2/3 times the quantity, 1 plus e to the x to the 3/2 plus c. All right, so that's our first review. I'll make a second review as well, so some extra practice problems. Let me know if you have any questions.